Now we'll start here. And the kinematic. Now we'll start your kinematic equation. Now we'll start here. Kinematic equation. Now we'll start your kinematic equation. Now we'll start here. Now start here. Now start your kinematic equation. उधर जाओ घर उधर। Now start your kinematic equation. Kinematic equation. Now the topic is kinematic equation. Kinematic equation form for uniformly accelerated motion. Accelerated motion. Now the kinematic equation. Now the kinematic equation for uniformly accelerated motion. Suppose an object Suppose an object is under informally accelerated motion. Suppose an object is under informally accelerated motion where acceleration is a and applied force is on F. Okay? So when force is applied on the object, it has changed its position from P1 to P2. This position is P2. And this distance is x. This distance is x. Suppose when force F is applied, initial velocity of the object is v0 and final velocity is v. When it is This is the kinematic. Now the kinematic equation for informally accelerated motion. So suppose when force is applied F on a particle, it moves from position P1 to P2. Then initial velocity of the object is v0 and final velocity is v, and it travels with a distance x. Now, first equation is what? Now the first equation is what? V is equal to v0 plus at. Okay? This is the first equation, and second equation is x is equal to v0t plus half at square. This is the second equation, and third equation is what? Third equation is v square is equal to v0 square plus 2ax. Take. Now what is b? B is what? B is the final velocity. Here v is the final velocity. And v0 is the initial velocity. v0 is initial v is the final velocity, and v0 is the initial velocity, and E is the acceleration, and this is the kinematic. These are three kinematic equations for uniformly accelerated motion. There are three kinematic equations for uniformly accelerated motion, where v is the final velocity, v0 is the initial velocity, e is the acceleration, and t is the time, and x is the distance traveled by the particle under uniform motion. Okay. Please note down this. It could be, let's say the velocity is 0. When initial velocity is 0, when initial velocity v0 is equal to 0, then what happened? Then first kinematic equation is what? V is equal to at. Second is equal to x is equal to half at square, and third v square is equal to 2ax. When initial velocity of the object is 0, then v is equal to 80, ax is equal to half at square, and v square is equal to 2ax. And suppose this is the object. When object is under application of a force, when force is applied on the object, then it will have some acceleration a and velocity. Suppose velocity is v0. Then when force is applied, then its position is changed from p1 to p2. Then it will have final velocity v, acceleration a, and it will travel distance x. Then kinematic equation R. First is equal to v0 plus 80. Second is what? H is equal to v0 t plus half 80 square. ठीक. X is equal to, and third equation is what? And third equation is what? H is equal to v0. Third equation is v square is equal to v0 square plus 2ax. This is the third equation. Now the fall under gravity and the kinematic equation in case of fall under gravity. Now the new topic is what? And the kinematic equation in case of fall under gravity. Fall under gravity when object is dropped towards earth from a height h. Suppose here inertial velocity is v0, then acceleration is what? Under gravity. When object is falled when object is falled from a height h, then acceleration acting on the body object is gravity. Acceleration of gravity. Then acceleration is equal to g. हाइट एस से फॉल कर रहा है, तो सपोज हियर जब ऑब्जेक्ट यहाँ से टकराएगा तो इन दिस केस वेलोसिटी हमारी मान भी है. देन फर्स्ट काइनेटिक इक्वेशन इज व्हाट? v इज इक्वल टू v0 प्लस gt. ए की जगह पे हमने t रख दिया प्लस t. एंड सेकेंड इक्वेशन जो बनेगा हमारा h इक्वल टू v0 t plus half gt square. This is the second equation. The kinematic equation in case of fall under gravity, when an object is dropped from a height h with a velocity v0, then when an object is from a height h, when an object is collide with earth surface, then final velocity is v. Then what happened? Then acceleration is equal to earth gravity. Acceleration is equal to acceleration of gravity. The gravity acceleration is g. Then you put in the kinematic equation a equal to j. Then we have first equation is v is equal to v0 plus gt. Second equation is equal to h equal to v0 t plus half gt square. And third equation is v square v0 square plus 2gh. This is the third equation. Now in case of free fall, in case of free fall under gravity, in case of free fall under gravity, in case of free fall under gravity, v0 is equal to 0. Then first equation is equal to what? V is equal to gt. Second equation, h is equal to half gt square. Second equation, h is equal to half gt square. Half gt square. And third equation is what? And third equation is v square is equal to 2gh. These are the kinematic equation in case of free fall under gravity. These are the three kinematic equations in case of free fall under gravity. Now the third condition is when object is driven towards upward direction with velocity v0 to a height h. Right? When object is thrown towards upward direction. When object is thrown towards upward direction to a height h with velocity v0, जब h पे पहुंचेगा ऑब्जेक्ट यहाँ पे फाइनल वेलोसिटी मान लेते हैं कि v है. then in this case acceleration जो होगा, acceleration यानी कि ग्रेविटी के अगेंस्ट मूव कर रहा है ऑब्जेक्ट. The object is moving against gravity, earth gravity. Here object is moving against earth gravity, therefore there is a deceleration. There is a case of deceleration. In case of deceleration, E is equal to what? Minus c. This is the case of deceleration. In case of deceleration, acceleration is equal to minus g. Let's see. The first equation is what? V is equal to v0 minus gt. Second equation, h equal to v0 t minus half gt square. ठीक. And third equation is what? And third equation is what? V square is equal to v0 square minus 2gh. This is the kinematic equation for uniformly accelerated motion. Now the Newton's law of motion. Now the topic is now the topic is Newton's law of motion. Newton's law of motion. There are three laws of motion. Newton's first law, Newton's first law. Second is the Newton's second law, and third is the Newton's third law. There are three laws of motion. There are Newton's law of motion. The Newton's law of motion, we have three types. There are three Newton's law, more Newton's law of motion. There are three Newton's law of motion: Newton's first law, Newton's second law, and Newton's third law. Okay. Now, what is the Newton's first law? Newton's first law is what? Newton's first law is what? According to this law, every body continues to be in a state of rest. According to this law, according to this law, every body continues to be in a state of rest. Rest or a all uniform motion in a straight line in a straight line unless a force is applied. Unless external force is applied on body. Take Newton's first law is what? What is the Newton's first law? According to this law, every body continues to be in a state of rest. A state of rest in a straight line. Okay? According to this law, every body continues to be in a state of rest. Rest or uniform motion in a straight line unless external force is applied. Okay? According to this law, what is Newton's first law? According to Newton's first law, every body continues to be in a state of rest or uniform motion in a straight line unless external forces applied on the body. Okay? What is Newton's first law? Newton's first law is what? According to this law. According to this law, every body continued to be in a state of rest or in uniform motion in a straight line unless external force is applied on the object. And Newton's second law of motion is what? Newton's second law of motion. The Newton's second law. Newton's second law is what? According to this law, applied force on a particle is directly proportional to rate of change of momentum. According to this law is what? According to this law, applied force according to this law applied force on a particle according to this law applied force on a particle is directly proportional to according to this law applied force on a particle is directly proportional to rate of change of momentum. Rate of change of momentum. Okay? And Newton's second law is what? According to this law, applied force on a particle is directly proportional to rate of change of momentum. The Newton's second law is what? What is the Newton's second law? According to this law, applied force on a particle is directly proportional to rate of change of momentum. What is the rate of change of momentum? The force is directly proportional to what? Force is directly proportional to rate of change of momentum. Force is directly proportional to rate of change of momentum. Yeah, we can say F is directly proportional to del P over del T. इसी को प्रोपोर्शनलिटी को हटाने के लिए कांस्टेंट लगता है F इजकल टू K del P ओवर del T. ठीक, K इजकल टू यूनिटी होता है, ये K इजकल टू यूनिटी मान लेते हैं फॉर सिंपलिसिटी, तो F इजकल टू del P ओवर del T कर सकते हैं. ठीक, तो व्हाट इज द न्यूटन सेकंड लॉ? तो अकॉर्डिंग टू न्यूटन सेकंड लॉ इज व्हाट? According to Newton's second law, applied force on a particle is directly proportional to rate of change of momentum. According to Newton's second law of motion, according to Newton's second law of motion, applied force on a particle is directly proportional to rate of change of momentum. The Newton's third law. What is the Newton's third law? Newton's third law is what? According to Newton's third law, for every action there is equal and opposite reaction. ठीक, Newton's third law. According to Newton's third law, according to Newton's third law is what? According to Newton's third law, for every action, according to this law, according to this law, for every action, according to this law, for every action, there is equal equal and opposite reaction. According to this law, for every action there is equal and opposite reaction. Okay, so what is the Newton's third law? The account of Newton's third law. According to Newton's third law, for every action there is equal and opposite reaction. According to Newton's third law, according to Newton's third law, for every action there is equal and opposite reaction. According to Newton's third law, according to according to Newton's third law, for every action there is equal and opposite reaction. Suppose there is a particle. Suppose this is a particle. सपोज यहाँ पे एक फोर्स हमने अप्लाई किया F1, ठीक। जब F1 से इसको प्रेस करेंगे पार्टिकल को नीचे की तरफ, तो इसके पर इस पर इक्वल एंड अपोजिट ऊपर की तरफ जो अर्थ बेस पे एक सेम अपोजिट डायरेक्शन फोर्स अप्लाई करेगी, तो F1 जो होगा F1 इज इक्वल टू माइनस F2, ठीक। दोनों तो ये क्या है, एक्शन है, this is the action and this is the reaction. F1 is equal to minus F2. The account of Newton's third law. For every action there is equal and opposite reaction. The according to Newton's third law, for every action there is equal and opposite reaction. ठीक, this is all about the kinematic equation power. This is all about the Newton's law. This is all about Newton's law. Now we will meet tomorrow with the next topic. Please share and subscribe my channel. Okay? Now we will meet tomorrow with a new topic. If you have any confusion, please comment in the comment box, and please share and please like and subscribe my channel. अच्छा, एक बात